Hello everyone, hope all of you are doing well. And in today's video, we're going to have a look at lesson 9.2, which is using the nth term. All right, so the first thing that we need to know actually is what is n? We just need to remember what n is. So if I got a sequence like this one over here, 1, 4, 9, 16, n refers to actually the number or the position of the term. So for example here, 1 is the first term. So n is actually here 1. And then we got here the second term is 4. The third term is 9. The fourth term is 16. So what is happening to n so that it gives me this sequence? So if you noticed over here in this question, we need to identify the cards that should be matching with each other from the yellow cards and the blue cards. So for example here, n cubed, what is the first term going to be? If I cube the position, the first term, it has a position 1. So 1 cubed is going to be what? 1. Then the second term, which is actually 2 cubed, which is going to be 8. The third term is going to be 3 cubed, which is 27, and so on. So if you notice over here, I'm talking about C. So C is actually the first one, n cubed. All right. If I'm talking about n, it just means 1, then 2, then 3, then 4, which is this one. As we agreed here, n is the position of the term. So the position of the first term is 1. So they're saying to you that the sequence is the same exactly like the position of each term. So each term is the same like its position. It is the term 1 and it is 1. Term 2 and it is 2. Okay? All right. So the third here, they're saying to you n over 2. What is n over 2? Well, n over 2 means the first term, which is 1 over 2. So you got here 1 over 2. The second term, which is 2, the second term over 2, which is actually going to be a 1. Then we got the third term, which is 3 over 2. 3 over 2, and so on. So I got half, 1, 3 over 2. We're talking here about B with the third one there. Okay, this is with this. And this here is with the first. And this here is with the second. All right, the last one, n squared. It means the first position, position number 1, squared is actually going to be 1. The position number 2, which is 2 squared, is going to become 4. Then the third term is 3 squared, which is going to become a 9. And that gives us sequence A. So sequence A is with Ivy. Here you go. Okay. All right. So let's continue here with the following sequence. Look at this here. The saying to the cards show one term from two different sequences. So eighth term in the sequence, nth term is n squared minus 14. So what is the eighth term going to be? The eighth term, what is it going to be here? All right, I'm going to remove the n and write 8. So it's going to be 8 squared minus 14, which is going to be what? 64 minus 14, which is going to be what? 50. All right, so this is actually the eighth term. 20th term in this sequence, or in this, using this nth term. So what is going to happen? I'm going to need to remove n and write 20. Look at that. Let's remove this. So it is 4 over 5 multiplied by n, which is, they wanted the 20th term. So it is times 20. And then add to it 33. We took this in the fractions unit. All right, how can I do it? You can simplify using the cross-canceling method. Bye-bye gives us 1 divided by 5 is 1 divided by 5 is 4. Now we can multiply normally. 4 by 4 is 16. 1 by 1 is 1. It's 16 over 1, which is just 16. Plus 33 is equal to 49. All right. So here, let's go to this sequence. I have here 2, 5, 10, 17, 26, 37. There are two types of sequences that we're going to talk about right now. We got linear and we got the quadratic. It comes a lot that they request from you to determine if this sequence is linear or quadratic, or they can say to you neither or neither. All right, so let's see. Is this linear, quadratic, or neither? How can I know? You need to check the difference between each term and the one after it. So for example here, what is happening here? I added 3, and then I added 5, and then I added 7, and then I added 9, then I added here 11. Good. Are they the same? Am I adding every time the same amount? No. Then definitely it is not linear. Not linear. If it was the same, the first difference is the same, and first differences are all the same, then it would have been linear. But here, the first differences are not the same, so it is not linear. Let's check the second differences. I mean, from the 3 to the 5, I added a 2. 5 to the 7, added a 2. 7 to the 9, added a 2. 9 to the 11, I added a 2. The second differences are the same, then it is quadratic. Okay, so this sequence is quadratic. Why? Because the second differences are the same. So let's have a look at a sequence that has the first differences the same. Look at this sequence here. What happened to the 6 to become 8? Added the 2. Ended the 8 to the 10. Added a 2. 10 to 12. Added a 2. And so on. We keep adding a 2. First differences are the same from the first time? Yes. So it is linear. How can I find now? So now we learned the difference between linear and quadratic. How can I find the nth term of a linear sequence? So I got here a linear sequence. How can I find the nth term? Nth term. The first thing that you need to do is to find the term-to-term rule. Here we agreed we're adding a 2 every time. So it is definitely 2n. 2n. That's it, Mr. Yes, it's every time. No, that's not it yet. But the first step is to check the difference. Every time I'm adding a 2, then it's to add. What if it was every time I'm adding a 5? If it was, then it's going to be 5n. But this is not the case. Now I'm adding a 2 every time only, so it is 2n. That's it? No, you need to check term 0. What is term 0? 0. Where's term 1? The first term here is what? Is 6. What is the term that would be before the 6? So if I go back, what is the term going to be here? Okay, Mister, that would have been a 4 because it's 4, 6, 8, 10. So the term before the first is 4. It's positive 4, right? Yes, so positive 4 here. Thank you. Again, all what I've done is that I checked the first term. I just checked here. Sorry. I checked here the difference between each term and the other. So I'm adding a 2, adding a 2, adding a 2. Then, Mister, it is going to be 2n. All right, then what about term 0, the term before the first? The term before the first is actually a 4. So it is positive 4. This is how I find the nth term of a linear sequence. They might request from me to find, for example, the 90th term. So they might say to you, find the 90th term. So I'm just going to replace n or substitute for n with 90. So it is 2 times 90 plus 4. 2 times 90 is 180 plus 4, 184. So I use now the nth term to find the 90th term in actually around like 10 seconds only. Okay. What if it wasn't a linear sequence? If it was a quadratic sequence like this one here that we've done? All right, no problem. I proved first that it is quadratic, right? Yes. How did I prove that it is quadratic? I proved that it's quadratic when I found that the second differences are the same. The second differences are the same, then definitely here we're dealing with n squared. That means it's a quadratic sequence. Quadratic sequence means n squared. All right, so now I found the n squared. What is after that? I need to try. If it was the first term, which means 1 squared, what would happen? 1 squared is only 1, right? So I need how many more for this to be a 2? Oh, mister, you need to add only 1 to it. Because if you want to check the first term, so 1 squared is 1. I need 1 more to become a 2, about plus 1. So let's try this. If it was the second term, how would I do it? 2 squared then. It would have been 2 squared plus 1. It will give me 5. 2 squared is 4, plus 1 is 5. All right, what if I wanted the third term? The third term, which is this one. All right, 3 squared is 9, plus 1 is 10. Then, mister, it worked. I checked around like 3 terms or 4 terms right now. Even if you continue with the rest of the terms, it will work. All what I've done is that once I knew it is a quadratic sequence, I just wrote n squared. And then I needed to check if it's added to it something or subtract from it something, or only n squared is enough. I found that no, I need to add n squared is not enough because the first term is not only 1, because 1 squared is 1, but the first term is not 1, it is a 2, then add 1 to it. I checked with the second, the third, the fourth term. I found that my rule is correct. Thank you and see you in another video.